before we get started, are there any questions over any of the assignments thus far? Questions on the homework assignments?
How you doing, bro?
Yep.
I don't know if I did these right. Like the ones that have X's on them.
So square root of negative 11. For square root of negative 11, well, the negative would come out as I, but we still have the square root of 11. The square root of 11 is the square root of 11, so it would be 4i square root of. Reduce it if it can. If it whatever can't, we leave inside the radical. Questions on this here? What we're doing today is solving problems by completing the square. All right, guys. We're solving equations, solving these quadratics by completing the square. Now, there's 4 main steps in completing the square. The first step is a equal to 1. If not, make it so. Get the variables. Guys. Themselves. And leave 2 spaces. So step 1 is a equal to 1. If not, make it so. Our second step is to get the variables by themselves and leave 2 spaces. This third step is to find C, which is our b over 2 squared, and plug in. Is a equal to 1? So, is a equal to 1? If not, make it so. If not, make it so. Step 2. Leave 2 spaces. Third, find C. B over 2 squared. And plug it in. Factor and solve. So these here are the 4 main steps that we need to do to be able to do or solve by completing the square. We're actually going to skip to problem number 7 because we did the first 2 yesterday. Well, the first 2 what they are yesterday, because it's x squared minus 16x plus 64 is already a perfect square trinomial. We can rewrite it as a set of parentheses squared and solve it there. So I want to start off with these here. And we're going to go through these steps to solve these by completing the square. And the completing the square method works on any and all quadratics. It doesn't matter what the solutions are or how it's set up, it will always work. Because if we look at this first one here, x squared minus 4x plus 8, and we try to graph this here. Hit graph, but we can see it does not cross the x-axis. So that means graphing will not work to solve this. It also means factoring doesn't work. I mean, it technically does, but you'd have to know the solutions to be able to find them. So all the methods that we have so far will not work. So we need to use completing the square. First step in completing the square is a equal to 1. And when we talk about a, it's in reference to our ax squared plus bx plus c equals 0. So a is our term in front of x squared. The number in front of x squared is the number in front of x squared 1. Well, the number in front. Anytime we don't have a number in front of a variable, it's understood to be 1. So it is 1. So we're good with the first step. Second step, get the variables by themselves. So we need to get the x squared and negative 4x on one side, everything else on the other. And we can do that by minusing 8 from both sides. So we will have x squared minus 4x. Now the other part of that step was to what? Leave 2 spaces. So we'll have 2 spaces added in. Because again, what we're trying to do is to make a perfect square trinomial. We're trying to turn x squared minus 4x plus a number into a set of parentheses squared. We need what number to plug in that spot to make it into a set of parentheses squared. So that's our value of c. And step 3 is to find c. And c is defined to be b over 2 squared. Yes, but almost. Negative 4. Because our value b will be the number in front of x, which is negative 4, because we take the sign with it. Now the next step is to simplify this here. Negative, almost, yes, it will be negative, or it will be 16. No, it won't be 16. Negative 4 over 2, negative 4 divided by 2 is negative 2. And negative 2 squared is 4. So we plug 4 into both spots. Now we could do parentheses negative 4 over 2, close parentheses squared, type it in, hit enter, and it would give us 4. It'll give us the answer. But it's good to do each step out. And that reason for that is because when we go to factor this, part of step 4, we will always have that set of parentheses squared and x. And the number that goes inside the parentheses will be whatever's inside the parentheses before we square it, so minus 2. And that will work out that way every single time. That's why it's nice to do the division first, then square it. Now the other side, negative 8 plus 4 is negative 4. Almost, because we need to get x by itself, so we need to finish solving. Questions on any of this so far? Now the next step is to take the square root of both sides. Square root of both sides, because on the left-hand side, the square root and square will cancel, leaving us with because whenever we take square root of both sides, we have to include the plus or minus. Now we need to take the square root of negative 4. Well, the negative will come out as, and the square root of 4 is, because the square root of a negative is I, or really the square root of negative 1 is I. Then we can take the square root of 4 and get 2. Questions on this here? Is x by itself? Yes.
I have a question that's kind of off topic.
I do not know. It'd be nice to have, but
You have to remember how to do all this.
most of the time, if you're needing a formula, they will provide it in the question, but some of them don't. So, last step is 2. Add 2 to both sides. Negative 2 plus 2 will simplify out, leaving us with x by itself. Whenever we add or subtract a number, we want to put it in front of the plus or minus. So we have x equals 2 plus or minus 2i. Is 2 and 2i, are they like terms? No. Since they're not like terms, we can't add or subtract them. This is the final answer. So x is equal to 2 plus or minus 2i. So we do have 2 actual statements. We have 2 plus I, 2 plus 2i, and 2 minus 2i. We don't have to check it, but if we wanted to, we could. Because I could grab either well, actually just the graphing calculator, and say 2 plus 2i squared, because I replaced the x squared, plugged in one of our answers into it. Then we have minus 4 times 2 plus 2i plus 8. So I replaced x, both x's with 2 plus 2i, yes? And what did the equation said it equaled? 0, yes? And that is what we get. It does work. I could do the same thing, bring it down, and instead of plus, we also have minus. And our other answer, 2 minus 2i, also gives us 0. So both of them work. It's another way to check it just to make sure. Questions on this here? Now again, with this here, there are several steps that we have to do through the entire process. But each individual step, there's not a whole lot to it. Because the first step is what? Is a equal to 1? Is yes. Okay, we move to step 2. Get the variables by themselves. We want all the variables on one side, all of our numbers without a variable on the other, and we're going to leave 2 spaces. So for this here, we would add 5. Since the 5 is negative, negative 5 plus 5 gives us 0. And on the other side, we would have 5. Again. Now at this point here, that gets us through steps 1 and 2. Step number 3, we need to find the value of c to make this a perfect square. Yes, it is 16 this time. And to get that, we need the value b, and the value b is almost not 8x, just 8. Because we're going back to our ax squared plus bx plus c. A, b, and c will all be numbers. They won't contain the variable x, y, any variable. And since it's plus 8 in front of the x, we'd have 8. 8 divided by 2 is 4. And 4 squared is 16. Questions on steps 1 through 3? Now we need to factor. So we'll have our set of parentheses squared. We will have x, and the number that goes in there is also the number we have before we squared, so it would be plus 4 since it was positive 4. And on the other side, 5 plus 16 is 21. Now at this point here, we need to solve. First step in solving is square root both sides. On the left-hand side, the square root and square would cancel, leaving us with x plus 4 equals plus or minus. Then you take square root of 21.
There's now a square root.
So it's just square root of 21. Because the answer that we would have would be a non-repeating, non-terminating decimal. And it would most likely be somewhere close to 4.6, 4.7, somewhere in there. But it doesn't matter what it actually is, because we're going to leave it as the square root of 21. Now at this point here, we would tell you. Is negative 4 and the square root of 21 like terms? So our final answer is this here.
Yep.
And again, just like with the last one, we could plug this into the calculator, say negative 4 plus the square root of 21 squared plus 8 times negative 4 plus the square root of 21 minus 5. Hit enter and it will give us 0. It'll give us the 2 spots. Questions on this here? Question on any of this so far? Is a equal to 1? So our first step was is a equal to 1? So no. If not, make it so.
Divided by it?
Divide everything by what? 3. Let's go with this one this time. So we're going to divide everything by 3. Now this problem is nice because when we divide everything by 3, well, 3x squared divided by 3 is x squared. 12x divided by 3 is plus 4x. And 15 divided by 3 is plus 5. And the most challenging one of them all, 0 divided by 3 is 0. Because the main first step with completing the squares, we need the number in front of x squared to be 1. And more specifically, we need it to be positive 1. So if it had been just negative x squared, we would divide everything by negative 1 to get what we need. Now we're going to subtract 5 from both sides and leave 2 spaces. So we have x squared plus 4x plus blank is equal to negative 5 plus blank. Now we are guaranteed that the value of c will be positive every single time. Because when we find the value of c, it's equal to b over 2 squared. Anytime we multiply a real number by itself, it's going to be positive. That's the only case that we can have. Now in our case, the value of b is indeed positive 4. 4 divided by 2 is 2, and 2 squared is 4. So we'll plug our 4 plus 4, we'll add it to both sides. So our x squared plus 4x will factor down because we'll have our parentheses in x. And we'd have plus 2 because the number we factored or had before we squared it was positive 2. So we have plus 2. Negative 5 plus 4 is negative 1. Questions on this here? Now we're going to take square root of both sides. Here the square root and square will cancel out, telling us that x plus 2 is equal to plus or minus 1i. Just I. Because by definition, I is the square root of negative 1, so we get this here. And lastly, we will subtract 2. That's it. Questions on any of this here? Not yet. Because I want to do at least one more with this here.
Oh, it's -10.
So exactly, we would divide everything by -3. Since a is not equal to 1, we need to make it so. So we'll divide everything by -3. Because -3x squared divided by -3 is x squared. -18x divided by -3 would be?
6.
Would be 6x. But what would our sign be?
Oh, plus.
Because a negative divided by a negative is a positive. -3 or -6 divided by -3. Because our -6 divided by -3, negative again make a positive. And lastly, 0 divided by -3 is 0, because 0 can't be positive or negative. Step 2, get the variables by themselves and leave 2 spaces. So here we can subtract 2 from both sides, telling us that x squared plus 6x plus blank is equal to -2 plus blank. Now we need to find the value of c. c is equal to b over 2 squared. Our value of b in this case is 6 divided by 2 is, and 3 squared is,
I'm sorry. Once I get it, my mental math is insane. I can just break it down in my head real quick.
questions on how we got to this point here. Now we need to factor x squared plus 6x plus 9. So we'd have x plus 3, because the number inside the parentheses before we squared it was positive 3. So we'd have plus 3. -2 plus 9 is 7. Then we would square root both sides. Square root and square would cancel. So we have x plus 3 plus just square root of my 7. Almost, not plus. So it'd be -3. So -3 plus or minus the square root of 7. Questions on any of this here? Do we feel comfortable with these here? Maybe? one more? Yeah. So, no matter how they're set up, the first thing we want to do, I mean, if there's more than one x squared or there are x's in other places, get them all together. That's the first thing I would say. Because if it doesn't have this, but if we had, say, plus 8x over here, minus the 8x, get them all on the same side first. But here, we don't have that. But all the x squareds are in one place. All the x's are in one place, so we're good there. So is a equal to 1? So we need to make it so by, yes. We're going to divide everything by 4. Now we don't necessarily have to get it equal to 0, but we can if we want to before we do this, or we can do this here. Because 4x squared divided by 4 is x squared. Plus x equals -17. So we divide each one of them by 4. Now this one is a little bit nicer, mainly because when we hit step 2, get the variables by themselves and leave 2 spaces. Are the variables by themselves? Yeah. So all we need is just to make a little bit of room. Or if I notice that the variables are already by themselves, when I divided by 4, I could have left those two spaces already. So, questions on this here? Question on any of this so far? C is equal to b over 2 squared. Now our value of b in this case is 8. B is always going to be the number in front of x. The only time that we can't necessarily say that's true is if I had 8x on one side and 7x on the other. They're not together. We need to put them together so that we get our true value of b. Now I would divide it first. 8 divided by 2 is, and 4 squared is 16. Now our negative 17 plus 16 is negative 1. So our factor, when we factor x squared plus 8x plus 16, we will have x. The number that goes in there with it will be 4, and it would be plus. Now at this point here, we will square root both sides, telling us that x plus 4 is equal to plus or minus. Yep.
Is that one a little off?
Yeah.
It would be I.
It would be I. Square root of negative 1 is I. I. Yeah. The graphing calculator will do it nicely as long as whatever the number is a perfect square. I, by definition, is negative 1. Square root of negative 1, so it's just going to come out as I. So if we had negative 4, square root of negative 4, graphing calculator will tell us 2i. The only one that we have an issue with, kind of we started off at the beginning, not for a problem, but just 4 times the square root of negative 11. Because 11 is not a perfect square.
I need Riley, Shelley, and Quincy to see some of the office, please. Riley, Shelley, and Quincy.
So the graphing calculator will tell us the decimal approximation. It won't tell us the exact answer. So for those, we take the negative out as I, because I think I did that earlier, wrote it as I, then took the square root of the number. So then we take square root of 11, it's just square root of 11, so I squared of 11. Does that make sense? So that's all we have for that there. All right, guys. Last thing we would do is subtract 4 from both sides.
It would be negative 4 plus or minus I.
Dang, you write fast. You write faster than I can say it.
Questions on any of this here? Yeah. Okay. Any questions on anything we've done so far?
But I'm kind of excited for the rules.
So do we feel comfortable with these here? Now there is one other method that works every time. So guys, let's focus up here. So at the start of this chapter, I said there's 2 methods that work for solving any quadratics. One of them is completing the square. It works with any and all quadratics. There is a second one that's called the quadratic formula.
I like this.
That's a Pythagorean theorem. Now, I want to show you all this here because this formula works. This is the general form for any quadratic. If we have a quadratic, it always comes in this form here. Yes? And we said that this here solves any quadratic, no matter what the values are. So I would not write this down. I would just kind of watch, because this can get a little tricky, a little messy. Because what I'm going to do is take these steps that we did for completing the square and apply it to that. So when we look at this here, is a equal to 1? Well, no. We have a value of a. So I'm going to divide everything by a, which is going to tell us that we have x squared plus b over ax plus c over a is equal to 0. Now, you'll never have to actually do this. Now, at this point, we want to get the variables by themselves. I'm going to subtract this over. This becomes 0. Plus, we leave a blank equals negative c over a plus blank. Now, our c term, the term that we plug in there, is equal to b over 2 squared. Now, for us here, the b 2 squared. Now, this works out to be b over 2a, which when we square it is b squared over 4a. At this point here, we would factor, set of parentheses squared. We'd have x inside the parentheses before we squared it was b over 2a, and it is positive. Here, if we do combine like terms, we would have 4a on bottom. It'd be b squared minus 4ac. I'm not going to go through the whole process or make, especially that's just going through adding and subtracting fractions. More steps? No. Square root of both sides of these would cancel, telling us x is plus b over 2a is equal to plus or minus. The denominator for a, well, it should be squared, is going to simplify to 2a.
Like not even in college. I'm sorry.
In the numerator, we have b squared minus 4ac. The last step to getting this x by itself is to subtract b over 2a from both sides. b over 2a. And what that tells us is x is by itself. But that tells us x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. But did we ever set a value for a, b, and c? So a, b, and c can be any real number. So that means for any quadratic equation, all we've got to do is plug in b in its corresponding spot, a in its corresponding spot, and c, simplify. This is the quadratic formula. You don't have to do any of those steps there. I did that there to show you this is where the formula comes from. This is how we get it. Now you guys just have to use it.
I remember that specific, all the stuff that you did before, but that one. I remember using that one freshman year.
But that's it.